MgCl2 dissolving means I can write a reaction. Dissolving means I get ions, which means no diatomics because they're not pure elements. Balancing, and then I can find my heat of reaction. Products, so magnesium ion plus 2 times the chloride ion minus reactants, so the value for MgCl2 negative 462 plus 2 times negative 167.4. This is negative 796.8 minus negative 641.8. I get a heat of reaction of negative 155 kilojoules per mole. Now I use a proportion to take my 4 grams into account. 155 kilojoules is for coefficient of 1 magnesium chloride. We can find the kilojoules if I were to use 4 grams. So grams equals moles times molecular weight of magnesium chloride. And once I find those moles, they will go here in my proportion. So magnesium, 24, plus Cl2, molecular weight is 95. 4 divided by 95 gets me 0.042 moles of magnesium chloride times the 155, 6.526 kilojoules, or because this was a negative heat of reaction, were released by the reaction. Since this is happening in water, that water is going to absorb that heat. Reaction's releasing heat, therefore water's absorbing that heat. Water absorbing heat means the temperature will increase. Now that I'm about the water, I can use a Q equals mCp delta T. Multiplying this by 1,000 or moving the decimal to the right 3 times. 6,526 are my joules. Mass of water, Cp of water, solve for delta T. I get a delta T of 17.35, warmer. So if the water started at 20, it's going to change by 17.35. I'm adding because it's getting warmer, 37.35 degrees Celsius. If instead of just using an X here, you wanted to have your X represent your final temperature, because the water is getting warmer, its final temperature is bigger than its initial. I would set this up as X minus 20. When I solve for X on this one, that's my final temperature. I wouldn't do anything else to it.